Welcome to Calculus 2. This session, we're gonna study series. Up to now, we've worked a lot with the sequence, which is a list of number with the pattern and the rules. We also study behavior of sequence, which is limit of sequence. But now, we take next step. We wanna add all together. What's gonna happen? That we call series. What we're gonna study this lecture, we will understand series as the sum of terms of sequence. Then we're gonna learn difference between convergence and divergence series. Then recognize and evaluate geometric and telescoping series. If you take the sequence 1 over 2n, that's a sequence 1 over 2 square. Third term gonna be 1 over 2 cubed, so on. What if we add one by one? So first one is you guys add the first one, 1 over 2, that's 0.5. What if first term and second term? 1 over 2 plus 1 over 4, that's going to be 0.75. We add 3 terms, 1 over 2, 1 over 4, 1 over 8. That's going to be 0.875. We're going to add the first 4 terms, 1 over 2 to the 1 over 16. That's going to be 0.9375. We want to add the 5 first term, 1 over 2 to the 1 over 2 to the 5th power. That's going to be 0.96875. So I add all the first term to the 10th term. That's 0.9990. What if we're going to add all the sequence right there, guys? All the sequence together. What is the sum of this sequence? Can you guess? I think that's gonna be 1. That's we call sum of a series. That's we're gonna study this session. Before we introduce definition of infinity series, let's briefly introduce sigma notation. Sigma k equal 1 to n ak. What is mean by that, guys? This sigma notation gonna be sum. So let's say n equal 5, guys, n equal 5 gonna be sigma k start to 1 to 5 ak. Sigma means summation. Ak is a sequence. K start to 1 to 5. So k equal 1 meaning is we have first term a1. K equal 2 meaning is a2. K equal 3 meaning is a4. K4 meaning is a4. K5 meaning is A5. Sigma meaning is you add all together. That's the meaning of sigma. So let's have one more example. This time K equal 1 to n AK meaning is we're gonna add sequence from first term to the nth term. So A1, A2, A3, A4, A5, A6 until AN minus 1. Next term is AN. That's the last term. Add all together. That's the meaning of sigma, guys. So K equal 1, that's the start point. N is last term. Here is a sequence. That's how to understand sigma. Now, I give the definition of infinity series. Given an infinity sequence A1, A2, A3, A4, A5, sigma n equal 1 to infinity an, we're gonna add all the infinity sequence A1 plus A2 plus A3 plus A4. No ending, guys. Add all the sequence. How gonna find this sum? This is infinity sum. That's we're gonna study next slides. Let's define the partial sum of sequence, guys. Given a sequence an, that's the infinity sequence, I want to define partial sums Sn, S1, S2, S3, S4, S5. So I list of a sequence. A1 is 1, A2 is 1.5, A3 gonna be 1 over 3, A4 is 1 over 4, An is 1 over n. I want to define S1, that's S1 is going to be A1. That's the first term of the sequence. That's going to be 1. S2, I define S2 equal S1 plus add second term A2. S1 is A1, so A1 plus A2, which meaning is you add the two first term, 1 plus 1.5. S3 gonna be S3, second term of partial sum plus third term of sequence A3, which meaning is A1, A2, A3, you add the first three term. S4 gonna be S3 plus fourth term of sequence, which meaning is A1, A2, A3, A4, you add the first four terms. That's gonna be 1 plus 1.5 plus 1 over 3 plus 1/4. So An gonna be you add sequence from first term to the nth term. That's we here A1 plus An, sigma notation, k equal 1 to n, ak gonna be 1 over k. Here is a sigma notation of partial sum. Let's find the limit of partial sum. An is 1 over 2n, that's the sequence. We're gonna find partial sum of Sn first. S1 is 1.5. I'm gonna sketch on the graph. That's the S1. S2 gonna be first term, second term. You add up first term of sequence, second term of sequence. That's gonna be S2. S3 gonna be 1 over 2 plus 1 over 2 square plus 1 over 2 cube. Then sketch it. That's gonna be S3. S4 gonna be add the first four term of sequence, 1 over 2 plus until 1 over 2 fourth power. That's I sketch S4. Can you see where this partial sum goes? So n approach infinity, n is getting bigger and bigger, which meaning is you add one of each sequence to the partial sum. What kind of behavior of this partial sum? That's getting close 1, guys, right? So Sn, limit of n approach to infinity, Sn approach what? This partial sum go to 1. That's we say limit of partial sum. Previous slides, we illustrate limit of partial sum. Here is a formal definition of convergence or divergence of series. Given a sequence An, consider partial sum Sn, meaning is you sum up sequence from first to the nth term, that the sigma k equal 1 to n ak. This limit of partial sum exists. We can find the limit of partial sum, that's gonna be S. Then we're gonna say this series gonna be converge. Formal definition of series right here. Limit and approach to infinity Sn, that's the partial sum limit. Partial sum is sigma notation is sigma k 1 equal n ak. This partial sum, limit of this partial sum exists, gonna be S. We're gonna say infinity series converge, sum of infinity series gonna be S. Limit of partial sum does not exist, infinity series diverge. That's the formal definition of convergence and divergence of series. given the partial sum, we're gonna find S1, S2, S3 and the limit of partial sum. I give the partial sum, which meaning is sum of sequence from k equal 1 to n. Partial sum gonna be 2n over 3n plus 5. Let's find the S1, guys. S1 meaning is you plug in n equal 1. Numerator gonna be 2 times 1 over denominator 3 times 1 plus 5. That's gonna be 2 over 8. That's gonna be 1 over 4. S2 gonna be you plug in n equal 2. 2 times 2 is 4 over 6 plus 5. That's gonna be 4 over 11. N equals 3. S3, 2 times 3 is 6 over denominator 9 plus 5. That's gonna be 6 over 14. You can simplify. That's gonna be 3 over 7. That's you find S1, S2, S3. Now, we're gonna find the limit of partial sum. Limit of n approach to infinity as Cn. Sn gonna be 2n over 3n plus 5. That's the fraction form. We can use L'Hopital rule, guys. L'Hopital rule. Take a derivative 2n is 2. Take a derivative 3n plus 5. That's the 3. That's the limit of partial sum gonna be 2 over 3. What does it mean by that? This means infinity series of an gonna be 2 over 3. Another way is say infinity series converges. Sum of infinity series gonna be 2 over 3. Now, given the partial sum, we're gonna find the sequence this time. How gonna find the sequence? A1, A2, A3, and general term AN. So previous slide, we find S1, S2, S3. Let's check it out, guys, okay? S1 meaning is A1. So A1 equal S1. That's gonna be 1/4. S2 meaning is A1 plus A2. We know the A1. So we find the A2 gonna be S2 minus S1. A1 is S1. So we find A2 gonna be 4 over 11. That's S2 minus S1 is 1 over 4. We have 5 over 44. That's the A2. Guys, just look for the pattern. S3 gonna be A1 plus A2 plus A3. That's the 3 over 7. So we are looking for the A3, third term of sequence. So A1 plus A2 gonna be S2. So A3 gonna be S3 minus S2. S3 gonna be 3 over 7 minus S2 gonna be 4 over 11. That's gonna be 5 over 77. Can you see the pattern, everyone? A1 is S1. A2 gonna be S2 minus S1. A3 gonna be S3 minus S2. So we find Sn. Look at the Sn is add sequence from A1 to An. That's the Sn. Sn is 2n over 3n plus 5. What is A1 to the An minus 1? That's gonna be Sn minus 1. Now we can find the An. An gonna be Sn minus Sn minus 1. Sn gonna be 2n over 3n plus 5. Sn minus 1, n minus 1 here. So replace n with n minus 1, n minus 1. Let's simplify this term, guys. So we have An equal 2n over 3n plus 5. Here is the distribute 2. Numerator going to be 2n minus 2. Denominator 3n minus 3 plus 5. Negative 3 plus 5 gonna be 2. So we find the general term of sequence 2n over 3n plus 5 minus 2n minus 2 over 3n plus 2. Now we find the general term. So can you find the limit of an sequence? So take a limit an. So you have 2n over 3n plus 5 minus 2n minus 2 over 3n plus 2. Find each limit, guys, each limit. So 2n over 3n plus 5, limit of this, and limit of second term. You can apply L'Hopital rule, guys. Then take a derivative with each numerator denominate. That's gonna be 2 over 3. Exactly same to second term, 2 over 3. Limit of sequence gonna be 0. This is so important. We're gonna see in the series, guys, later. So we find the limit of sequence right there. Limit of sequence is 0. This partial sum is converge. We find the sum of infinity series. We're gonna take a look at the telescoping sum. Sometimes infinity series looks complicated at first, but a special cancellation pattern make them much simpler. These are called telescoping series. Look at this example right here, guys. This infinity series, it looks a little complicated, but we gonna find the infinity series, sum of infinity series. How gonna do this telescoping sum is, we gonna find the partial sum first. That's the definition of infinity series. Partial sum is I equal 1 to n, 1 over I minus 1 over I plus 1. So that's I gonna put that term is Sn. Let's find the partial sum. What gonna happen with this partial sum? I gonna expand this sigma. I equal 1, 1 minus 1 over 2. I equal to 1 over 2 minus 1 over 3. I equal n minus 1. 1 over n minus 1 minus n. I equal n. Last term is 1 over n minus 1 over n plus 1. Now you see 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 dot 1 over n minus 1 plus minus 1 over n, 1 over n minus 1 over n plus 1. What do you see, guys? Can you cancel out first term, second, 1 over 2, cancel out, second term, first one. That's cancel out. That's the you have cancel out, right? Guys, the first one is cancel out 1 and a half, 1 and a half. 1 over third is cancel out first of next parentheses. That's cancel out right there. 1 over n minus 2 probably cancel out previous parentheses, second term. That's why you cancel out. 1 over n minus 1 plus n minus 1 is cancel out. 1 over n cancel out. So you see what you have right now is 1 and less than we have. So partial sum gonna be 1 minus 1 over n plus 1. So middle part cancel out. We only have first term and last term we have. After you finding partial sum, we have to find the limit of partial sum. That's the sum of infinity series. So take a limit and approach to infinity. That's the sum of infinity series. And approach to infinity, partial sum gonna be limit and approach to infinity 1 minus 1 over n plus 1. Where do you go 1 over n plus 1, guys? And approach to infinity, that's going to 0, right? So we have limit of partial sum gonna be 1, which means telescoping sum, that's gonna be 1, guys. That's gonna be 1. Let's have one more telescoping sum here, guys. Summation I equal 1 to infinity ln I minus ln I plus 1. We want to find if this series gonna be converge or diverge. First step is you have to find the partial sum. So we're gonna write definition of this infinity series. That's gonna be limit and approach to infinity partial sum Sn. That's gonna be right here. That's gonna be partial sum Sn. So partial sum gonna be summation I equal 1 to n ln I minus ln I plus 1. So let's find the partial sum of this infinity series. Start with I equal 1. Last term gonna be n. So I equal 1 ln 1 minus ln 2. I equal 2 ln 2 minus ln 3. All the way I equal n minus 1 ln n minus 1 minus ln n. I equal n last term ln n minus ln n plus 1. Middle part is cancel out. Let's cancel out, guys. ln 1 minus ln 2 to the ln n minus ln n plus 1. Negative ln 2 cancel out ln 2. Negative ln 3 cancel out first term of next parenthesis. That's ln n minus 1. Negative ln n plus ln n. We have ln 1 minus ln n plus 1. That's why telescoping. Telescope middle part is gonna be unseen when you fold it, guys, right? So ln 1 is 0, right, guys? So we have partial sum is negative ln n plus 1. We want to find the sum of infinity series, meaning is we have to take a limit Sn, partial sum. What happened? ln function is an approach to infinity, they going to infinity, guys, okay? That's going to infinity, which meaning is in front of infinity is negative. This partial sum is going to negative infinity. Another way is say this telescoping series is diverge. Now, let's look at one of the most important type of series, geometric series. Geometric series is a sum of geometric sequence. Geometric sequence has first term and ratio, guys. So understand convergence of geometric series, we look at the partial sum right here. Partial sum has very neat formula. So of course, denominator cannot be 1 or ratio cannot be 1. So let's find the limit of this partial sum. So you're gonna find the limit of partial sum as an approach to infinity. What happened at Sn? So we're gonna see this limit depends on the ratio. This limit converges, diverge. See that? This is ratio. We did in the sequence, limit of sequence. R ratio gonna be between the negative 1 and 1, guys. Negative 1 and 1. Then Rn plus 1 going to 0. This limit go approach to a over 1 minus r. However, r is less than negative 1. R is greater than 1. This one is never close any number, which meaning is diverge. So geometric sequence gives one of the simplest but most popular convergence tests. So when R is between negative 1 and positive 1, this geometric series converges, then sum of geometric series gonna be a over 1 minus r. R is less than negative 1, r is greater than 1, r is negative 1, r is 1, geometric series diverge. Let's find the geometric series. First thing you have to do, identify this is geometric series. So best way identify geometric series, you expand the sigma. So let's expand this series, guys. Plug in the n equal 1, n equal 2, n equal 3. You see the pattern of a sequence, then you recognize this is geometric series. So I plug in the n equal 1, n equal 2, n equal 3. You have 3 over 2, 3 over 2 square, 3 over 2 cube. Then each term, how can make each term? 3 over 2 go to the 3 over 2 square. You times 1 over 2, which meaning is ratio gonna be 1 over 2 that you have. So that's why this is geometric series. Ratio is between the negative 1 and positive 1. Geometric series converges. So we have two formula for that. The sum of it geometric series gonna be A, that's the first term, over 1 minus ratio. What is the first term, guys? This one is gonna be 3 over 2. Ratio gonna be 1 over 2. You plug in there 3 over 2 over 1 minus 1 over 2. Then this gonna be 3 over 2 over 1 over 2. Simplify this one is 3 over 2 times 2 over 1. Answer gonna be 3. This sum of this geometric series gonna be 3 because ratio gonna be between negative 1 and positive 1. Let's have one more example of geometric series. This looks a little complicated, guys, right? Only way we recognize of geometric series is expand the sigma. So let's start expanding this sigma. N is 1. What is it? 2 to the 1's power 3 and 0. Second term, n is 1 is 2 square 3 minus 1. N equals 3, 2 to the 3, 3 to the negative 2. So now power is negative. That's going to be fraction. So we write this one 2 over 3, 0 is 1. 2 square over 3. 2 cube over 3 square. So let's figure it out. If this is geometric series or not. What happened each term? 2 square over 3, 2 cube over 3 square. What happened, guys? Each time, they times 2 over 3. Ratio is 2 over 3. That's the geometric series. Ratio is 2 over 3. Then the ratio between the negative 1 and 1, meaning is this geometric series converges. So we have to find the sum of geometric series. We need to find the first term and ratio. First term is 2. Ratio gonna be 2 over 3. Now we have sum of geometric series. 2 over 1 minus 2 over 3. That's gonna be 2 over 1 over 3. 2 times 3 over 1. Sum of geometric series gonna be 6. Before we dive in more convergence tests in the later lecture, it is important to remember some basic property. I'm gonna explain property of infinity series by showing the example. So this one is the sum of two series. So you're gonna separate this infinity series. So you're gonna have separate infinity series is two different infinity series. So first infinity series, we find the sum. Second infinity series, we're gonna find the sum. First infinity series gonna be telescoping. Second is gonna be geometric series. First telescoping sum, on the top is the constant. You're gonna take it out. So 3 times sum of infinity series plus sum of other infinity series. You already find each infinity series, sum of each infinity series, this one is gonna be one geometric series, one of two and equal one. Now, what is sum of this series gonna be? 3 times 1, because this sum of this infinite series is 1. That's a telescoping sum. Second part is geometric series. That's also 1. So this sum of this infinity series is gonna be 4. Let's have another example. We have difference of infinity series. You're gonna separate this infinity series first, then find the sum of each infinity series. First one is gonna be geometric series. Second, also geometric series. Second infinity series, geometric series, but R is ratio gonna be 5, which meaning is ratio is gonna be greater than 1. This series is gonna be diverse, which means this whole series is gonna be diverse. It doesn't matter. One is converge. It doesn't matter. One infinity series is diverse. Whole series is gonna be diverse. So this series is gonna be diverse. What do you learn from this lecture? We learn series is the sum of terms of a sequence. When we add up infinite terms, two things can happen. Sometimes the sum settles on a finite value, which meaning is that's convergence series. Other time, the sum keeps growing without the bound, or it oscillates. That's a divergence series. Look at the two key type of series. First one is geometric series. That's the sum of geometric sequence. Ratio gonna be between negative and 1. The series converges to the S. S gonna be first term over 1 minus R. Another important type of convergence, the infinity series gonna be telescoping series. Many terms cancel out, so when we expand the sum, only first term and the last term remains. This cancellation makes much easier to find the limit. These two examples show us both beauty and the power of infinity series. Sometimes a seemingly endless sum can be captured in a simple closed form.